Well, good day and welcome back to Characteristics Part 3. And this time we're going to go for it. This time it says graph. So we're going to take this miserable looking mess and we're going to attempt to graph it without the use of any technology. Okay? And I think we can do it. So we're going to start off by looking at, I guess, factoring it. Yeah, that's what we're going to do. So we're going to take out that common 2 on the top. So that would be x squared plus x minus 6. It looks like I might be able to factor that some more. And on the bottom, I can take out a common 4. So we can do that. All right, let's see what we get on the top. So that's 2. And then we're going to have x, looks like plus 3 and x minus 2. Just double check. Yep, that looks pretty good. And on the bottom, nothing we can do. We'll just leave it as is. Now, I can see right away, hey, look at this. I'm going to do some canceling here. And what's more, I can even divide the 2 into the 4. So here's what I end up with, is x minus 2 over 2. So let's start listing all the different characteristics. Vertical asymptotes, there are none. And that's because this one possible place canceled away, which means we have a hole. And that hole is when x is negative 3. You just got to figure out the corresponding y-coordinate. So we'll go to the end. Plug negative 3 in. Negative 3 minus 2 is negative 5 halves. All right. Next thing we want to do is look for any horizontal asymptotes. Okay, so we look at maybe the original function here, and it's pretty clear that it's a second degree on top and a first degree on the bottom. And that means essentially you have this sort of thing happening. These are the terms that would dominate, and this is going to turn into x over 2, which essentially means it's going to either blow up as you move to the right, or it's going to go to negative infinity as you move to the left. So the conclusion is, as far as horizontal asymptotes, there are none. Now, what about oblique asymptotes? Well, definitely is in the running, because as we said, even looking at this, or in the original, oh, that's a second degree over a first degree. So that probably means an oblique asymptote. But wait a minute, it would, except for one thing. It all canceled out and turned into this simpler form. So as far as oblique asymptotes are concerned, there really is none. And that's because everything canceled and simplified down to this. I mean, you wouldn't even use synthetic division on this simpler form, right? It doesn't warrant it. So no oblique asymptote either. Now, let's look for an x-intercept. See, is there any way we can turn the top into 0? Yes, when x is 2. And the 3, well, that we know is a hole in the graph, or sorry, the negative 3. So that's not going to bring us any x-intercept. And what about a y-intercept? Any way we can figure that out easily? Well, yeah, put in a 0 for x. If you go to the original function, it's probably the easiest. 0, 0, negative 12 over 0 plus positive 12. So it looks like it's negative 1. So I think I have everything I need to try and produce the graph. There's just one thing that I could use that I don't have, and that's more room here. So I'm going to have to delete this stuff, and then I'm going to do my drawing on the next page. So hopefully your notes are sitting in front of you, because I'm going to now clear the screen. So here we go. Let's get the grid built. Okay, so let's see, something like that. Nice big grid. Okay, so let's put in all the different ingredients. Now let's just put in some markings here. Okay, doesn't look too bad. I think we're going to be okay. Okay, so some important points. We have an x-intercept over here at 2, 0, and we have a y-intercept at 0, -1. We have a point of discontinuity at -3, -5 halves. Now, -5 halves is like -2.5, so it's approximately down here. There's our little hole in the graph. So I got those guys all figured out. Okay, then I guess the only thing left to do is try and figure out the graph, because we have no, let's see if I got this straight. There's no vertical asymptote, there's no horizontal asymptote, and there's no oblique asymptote. What does that leave us other than these points here and this hole? It leaves us the graph, and remember the simplified version that we had, it looked like this. Okay, when we did all the factoring and the canceling, we had it written like this. And it may not be obvious to you, but if I split this now, split it as x over 2, and then minus 2 over 2. So I'm splitting the fraction up. Or maybe I just write it like this, 1/2 x minus 1. What is this? You know, if somebody came along and said graph that, you'd say, oh, that's a line. The y-intercept is -1, and it's got a slope of 1/2. And you know what? That totally fits this picture. Except for the fact I won't be able to draw it very well, but I'm going to try. So I'm going to draw a line that goes through these points like this. And maybe I can even draw a line that halfway looks decent down this way. And there it is. We're just going to fill in this a bit better. There we go. And there's the graph. And you know, that would be totally reasonable for you to graph that without reaching for a graphing calculator. We've identified the hole in the graph. We've identified there's no asymptotes at all. And we know this kind of graph. We've graphed these for years. So that would be a very fair question on any quiz or test. And with that, I am going to stop. So we'll see you in the next chapter.